So today's teaching is actually going to take another dimension. We've actually not done this before. So I just decided to do this. I have an amazing personality in our midst. So he's going to be introducing himself. So before we start the teaching, I already informed you guys that we're going to be teaching on motion, we'll talk about types of motion, we'll also talk about relative motion. Then we'll make a clear difference between distance and displacement. That will be all for today's class. All right. I know this class is going to be an awesome one because we have a good personality now. So, like I said, he will be introducing himself. So I don't know if you can let the audience or my students know you better.
All right. So, hello everyone. My name is Miracle. I prefer people calling me the Miraculous actually. So I'm the Miraculous.
Miraculous. You do miracle with physics. All right, it's a scholar in case you don't know. So it will be doing justice to this topic we have before us, motion. So I don't know if you can just give us a brief explanation on what motion is. For many persons, they just say the word motion. If you actually try to define motion, what is the meaning of motion, they don't really know. So can you tell us what motion is?
So the truth is that physics generally is not compound. Don't mind what your textbook is telling you. Yes. It's just that we're going too far. We're not supposed to go too far. Now, when you talk about motion, actually, motion is talking about the displacement of a body through a distance. The truth is, in physics, motion is definitely the very basic concept. So when you talk about motion talks about how a body moves. Generally, is not difficult. It's just that maybe the terms our textbooks have used is very, very ambiguous for us to comprehend. But then, yes, so that's the reason why videos like this are important. So when you talk about motion, actually, motion is simple. A body is initially at point A, moves over a distance to another point B. Then you can refer to what that body has undergone as motion. So motion is not a very big concept like that. The change in position of a body from point A to point B is motion. Wow. As simple as that.
So we can simply define motion as the change in the position of a body from one point to another. All right. So if you are writing, please jot it down. Motion is the change in the position of a body from one point to another. You know, we cannot actually talk about motion without making reference to what causes motion.
Yes, that's true, sir. So it is essential to know that, in fact, according to Newton's first law tells us that a body will continue to be at rest that is not undergoing motion, except an external force. So what causes motion is actually a force. Until a body is acted upon by a force, then motion comes into play. And the truth is that not only in the context of motion actually. So for a body to go into motion, there should be an external force. For a body to also come to rest, a force is responsible to bring it back to rest.
That means for motion to be possible, there must be an application of force, an external force. So force causes motion. And let me quickly add to what you said, that the study of motion with respect of the force causing that motion is known as, they call it dynamics, right?
Yes.
Why the study of motion without making reference to the force causing it is kinematics.
Yes, kinematics.
Okay, please write it down. The study of motion in regards to the force causing the motion is known as dynamics.
Yeah.
Why the study of motion without making reference to the force causing that motion is known as kinematics. Okay, it's very important. Okay, let us quickly talk about the types of motion.
All right, so talking about the types of motion, you have different types of them. For example, there's one thing students don't know, and that thing is this: relative motion is not a type of motion. Please write that down, very important.
Take note, relative motion
is not a type of motion.
I actually thought that was confusing. Initially, when I teach, I usually mention relative motion as a type of motion.
Okay.
But when I was doing my study
yes,
today,
that's what many of your textbooks will carry, that relative motion is a type of motion. But this is the truth. Relative motion is not a type of motion. Why? That's simply because all types of motion are relative motion. I don't know if you get that. For example, translational motion is a type of relative motion. Oscillatory motion is a type of relative motion. Random motion is a type of relative motion.
So
now let's talk
for
about
those that are jotting. He has mentioned like 3 types of motion. Now, if you pay attention, you mentioned translational motion.
Yeah.
You mentioned oscillatory motion. You mentioned random motion. Okay.
Yes. So if you talk about relative motion, let's start with relative motion so that I explain to you why relative motion is not a type of motion. That's simply because when you talk about something relating to another, it means it is happening side by side. Like A is traveling relative to B. I don't know if you get what I'm saying. Okay, this is it. Any object that is moving with respect to a reference. And looking at the entire universe, we take the Earth as a reference point. So whatever is moving with respect to the Earth. The Earth remains static while you move. So you are doing that motion is a motion with respect to the Earth. So that type of motion is relative. So when you check a type of motion like translational motion, you check a type of motion like oscillatory, all motions are done with respect to the Earth. So since all motions are done with respect to the Earth, it therefore means that relative motion is not a type of motion, but all other types of motion encompasses relative motion.
Wow.
Yeah. Wow. So when you now talk about the different types of motion now, for example, the translational motion just talks about how a body moves from one point to another, keeping its body fixed. I don't know if you get what I'm saying.
Please, I don't know if you can just move an object so you can use that for analysis.
Okay. So assuming I have this.
You can use this as well.
Okay. So if this is to undergo translational motion, it means it is going from this point and it is coming like this to this point without a change in the state.
That means it's not rotating like this, it's not doing like this, it's just going from this point.
The same way it is. That's why it is called translational. So what's the meaning of something translating? It means it is just moving from one point to another without any change in its form. Yes, so that type of motion is the one you refer to as a translational kind of motion. Yeah. Then you have rotational motion. And another thing is this. Many people don't know the difference between rotational motion and circular motion. There's a difference between rotational motion and circular motion. But then before we get there, let's talk about vibrational motion. Vibrational motion is a type of motion you find in solids. Yes. Recall that solids are held together by strong intermolecular forces. Yes. So as you hit these solids, you tend to put the molecules into vibration. Yes. So, and this one is a type of motion that we really do not see with our eyes, but then it is very, very possible. It is in existence. Then when you talk about rotational motion, the motion of this body now is rotational. This is a rotational type of motion. So it is rotating about an axis. Now the difference between circular motion and rotational motion is this. For circular motion, the axis is attached to the body. I don't know if you get what I'm saying. So the body is rotating about its own axis. That's rotational motion.
Like, let me bring this fan so we'll understand it better. Okay. I think like what you mean, if let's say we put this on and this blade is rotating.
Yes, you discover that there is a center.
Yes.
And the blades are rotating about the center, which is a part of the entire stuff. You get? Yes. So that's a type of rotational motion, not circular motion. If it were circular, then the body will be going about
something like this.
A cycle that is not attached.
The entire body is going like this.
Yes, exactly, sir.
Circular motion.
Yes.
Take note, this is circular motion. Why rotational motion involves only the blade.
Yes.
Only the blade moving. It's not the entire body is not moving. It's just circling like the blades. Only the blades are circling. Okay. Thank you very much, sir.
Then why the last type of motion I would like to talk about is the random motion. The random motion just talks about the haphazard movement of particles. For example, the movement of dust particles, which is not following an organized path. Yes. So that's another type of motion. It's scattered kind of motion.
Okay. So another thing I want us to discuss is is it possible for a body to undergo two kinds of motion at the same
Yeah,
time?
a body can undergo two types of motion at the same time. For example, the motion of the tire of a vehicle. The motion of the tire of a vehicle is actually both rotational and translational.
So let's assume this is the tire of a vehicle now.
Yes.
Can you show it?
As it is rotating like this, the tire is not changing form. It is just
the tire is rolling.
Yes, it's rolling.
While the entire car is moving from one point to another.
Yeah. So the motion of the tire of a vehicle is actually both translational and rotational.
Wow, that's nice. Thank you very much. You've really opened my eyes personally to some things. Thank you very much. So another thing I want us to discuss is, I don't know if you can go back to this relative motion. There are some kind of little calculations there.
Okay, yeah, that's true. So finding relative motion is not actually difficult. What I do is that when I teach my students this thing, I always relate it to vectors.
Before we talk about the calculation aspect of this relative motion, let us talk about, under this relative motion, there are some kind of cases whereby they will tell you where you are in a bus and then the bus is moving, you see the trees, and those are the trees are moving.
Yes, that's relative motion actually. So when you are in a bus, that's why I said all motion happens with respect to the earth. You hold a ball, you throw it up. That ball is moving in the upward direction with respect to the earth.
Yes.
The trees are not moving, they are stagnant in their position, but as a result of you in a moving bus and the bus is speeding past these trees, it is looking as though they are moving. So that's a relative kind of motion, and the trees are substances grown up from the earth. So all types of motion are actually done relative to the earth. That's why relative motion in itself is not a type of motion, or because all motions are relative.
So I want you to know this now. Many times you guys will ask yourself, you are inside a bus, it looks as if the trees are moving. Actually, they are not moving. What makes it look as if they are moving is because your motion is relative to that of the earth.
Yes.
Right? So it looks as your bus is moving, or your car that you are in, as it's moving, it looks as if other objects around, they are moving backward. They are moving backward. Meanwhile, in reality, they are not moving backward. It is all as a result of relative.
And that's why there is a question that comes from this place, that a bus is moving at a speed of, let's assume, 3 meters per second, and you are sitting inside the bus. Okay, I think the way I found that question some time ago while I was preparing for JAMB was, a man sitting in a bus moving at a speed of 5 meters per second stretches his hand outside, throws a ball. They say, how long would he have traveled before he catches? That is option A, he catches the ball back. Option B, they traveled 3 meters and the ball landed on the floor. But then the answer to that question is actually the ball will return back to the man's hand. And the reason for that
means you are inside the bus and you throw
you stretch your
outside the bus.
Yes, like you stretch your hand outside through the window of the bus and you throw a ball up. The ball is going to return back to your hand. And the scenario there is simply this: because yourself and the ball are inside the vehicle, the moment you throw the ball also receives the same speed as the bus. So it is whatever happens to you that happens to since it is receiving the same speed as yourself, then the ball returns back.
Okay.
Yes.
Okay, based on that, I have a question. So when you're actually traveling inside of a bus, outside of it, there's a breeze,
and that's
push it
backward. That's reality actually, but in the theoretical aspect of it, we always neglect air resistance.
Neglecting air resistance.
All those stuff, yeah.
Okay.
Maybe not even outside, even inside the bus, as you throw it up, it returns back to your hand.
Okay.
Yes. So the scenario of because inside the bus, the same speed is what you encounter now.
Yeah.
Yes. So that one, they said pull your hand outside, is just a way to trick students. Yes. So that's the whole scenario. Okay. Because sitting inside the bus,
everything is moving at the same
velocity. Yeah. So it's like there's no acceleration.
Yes.
Since the initial velocity is the same as the final velocity, since there's no change in velocity, there can't be an acceleration. So as the ball is thrown up, it returns back to the same position.
Okay, let's go back to, we are still on relative motion. This relative motion, there are some kind of salient calculations I want you to just explain, whereby you are in a bus and then you are moving at a certain velocity different from the velocity of the bus. They do not need to find the relative
Yes.
motion of the body with respect to the head.
Yeah. So that calculation is not very difficult. A very simple one at that. Yeah. So it's just very simple. When you talk about vectors, you talk about how you add and subtract vectors. If they are moving in the same direction, you add. If they are moving in opposite direction, you subtract. But the reverse becomes the case when you are dealing with relative motion. If they are moving in the same direction, you subtract. If they are moving in opposite direction, you add.
Yeah. Please take note for relative motion, those calculations, if you encounter any calculation on relative motion that this body is moving at a velocity of this and that one is moving at a velocity of that, they say find the relative motion of this body with respect to the earth. If the two velocities are opposite, you said you what?
You add them.
You add them. If they are opposite, you add them. Let me just write an example so that you understand what I'm trying to say. I think there's an example here. Think, okay, they say suppose a bus is moving at 100 kilometers per hour.
All right.
Suppose a bus is moving at 100 kilometers per hour.
So we have 100 kilometers per hour.
And the person walks at 5 kilometers per hour towards the driver.
Okay, a bus moves at 100 kilometers per hour. Let's assume the bus is moving in this direction, 100 kilometers per hour.
Yes, and the person moves at 5 kilometers per hour towards the driver.
And the person moves at, this is the bus. The person moves at 5 kilometers per hour, 5 kilometers per hour.
Towards the driver.
Towards the driver.
Yes. So what is the relative velocity of the person with respect to the earth?
What is the of the person with respect to the earth?
Yeah.
Now I can't really fathom that question because for you to actually get the correct answer to questions like this, you have to be very, very concise with directions.
Okay.
So me finding the directions now, if the person is moving towards the driver, because if I show an arrow like this of the person moving towards the driver, that is likely to be correct.
Yes.
Yes, because the driver of the bus is in this direction and the person is moving towards the driver also in this direction. Then if I also show something like this,
that's in opposite direction.
Yes, that's also correct because as the bus is coming like this, the driver is here and this person is
I didn't actually read the question from the beginning. It was actually noted here that the guy was seated like behind the driver.
Because it is actually very difficult for me to get the analysis right without those information.
With the information I get to you, whether it starts from here, it's moving towards the driver.
It's moving towards the driver.
From here, it's moving towards the driver. The initial question is, it was noted like the guy was behind the driver before.
He is sitting at the back of the bus.
Yes.
And now he's moving towards the driver. All right. So this direction becomes what we are going to utilize for this calculation. So here is the person moving 5 kilometers per hour towards the driver. You get my point?
Yes.
So now the relative velocity here is not difficult to find. Looking at this now, they are moving in the same direction. Since they are moving in the same direction, the rule simply states that you should do what? You should subtract. If it were for vectors, you would have added them. But since it's not for vectors, you simply do what? Simply subtract. So the relative velocity here simply becomes 100 minus what? 5. And that will give you what? 95 kilometers per hour. This is the relative velocity.
Okay, let me read the question. A man is running at 2 meters per second.
A man, so the velocity of the man is 2 meters per second.
Towards the right.
Yeah.
A woman is running at 1 meter per second.
Okay, a woman is running at 1 meter per second.
The velocities are relative to the earth.
Okay.
Determine the velocity of the man relative to the woman if they are running in the same direction.
Now listen, they said if they are running in the same direction. So my diagram on the board is actually correct because I have the man running to the right. Now the question is saying I should find the relative velocity if they are running in the same direction. So like I said, if these people are going in the same direction, then the relative velocity is going to be this minus that. 2 minus 1. That will give us what? 1 meters per second. But if they now say find the velocity, because when you are dealing with relative motion, actually, there's something that is very, very important for you to note. Another thing is this. See, in physics, there are certain truths you should be aware of. And what I'm about to tell you now will help you so much. When you are dealing with a concept like momentum, where you are dealing with collisions. Yeah. Now, please note that we can use the general formula V relative is equal to the V of the object minus the V of the frame, that is respect to the frame. Now, in order for you to use this, you must take directions and signs very importantly, so that if this is going in this direction, I can attribute this direction as positive. If I attribute that direction as positive, it means that the other direction, if it is going the other direction is going to be negative. But for this, I can't say this is negative because they are both going in the same direction. So since I say this direction should be positive, and this person is also going in this direction, so this is also going to be positive. Then in that, you can apply this formula. And when you apply that formula, you are also going to get this. And another thing I want to mention is the fact that if they now say find the velocity of the woman, still as they are traveling in the same direction, with respect to the man, if your answer will now carry a negative sign.
Okay.
Why? Because it is now the reverse of what you have before.
Okay.
Yes. So that's how it's going to work. That's what I say.
Thank you very much. I believe with these understandings, you will be able to solve any question on that relative motion. And of course, you know how we usually do it. I will be dropping a link that would give you access to, questions for you to answer. All right. I believe you have learned one or two things. Yes. Thank you very much.
Thank you, sir.
Mr. Miracle. You have really done justice to this topic, and I believe my students have learned a lot today. We are blessed to have you.
I'm honored to be here.
All right.